Hey there, I'm Gregory Carlson, and let's continue learning about complex numbers. So let's imagine we had the following. The square root of negative 6 times the square root of negative 8. How would we simplify this? So you might just think that we can do the two numbers multiplied together, but that's not quite true because of our rules. We can only do that if we can only multiply them together if they're positive. So first we need to use this third rule to pull off the i's. So if you have the square root of negative 6 times the square root of negative 8, you need to rewrite that as I times the square root of 6, I times the square root of 8. So do you see how I did that? I pulled off the negative sign, made it an I, pulled off the negative sign, and made it an I. And so now we can simplify. I have I times I, which is equal to I squared. Whoops, and I have 6 times 8, the square root of 6 times the square root of 8, which is equal to the square root of 48. And so that's the correct way to simplify this. I times I is I squared. Square root of 6 times square root of 8 is square root of 48. And we know what I squared is. We know that I squared is equal to negative 1, or hopefully we know that. So in fact, this is the negative square root of 48. Okie dokie? So now we can do one more thing. We can simplify this. We want to think of the largest square number that goes into 48, and that number happens to be 16. 48 is equal to 16 times 3. And so that's the square root of 16 times the square root of 3. And we know that the square root of 16 is 4. So the answer to this is negative 4 root 3. So you'll notice that if you had just done negative 6 times negative 8, we would have lost our negative sign right here. So the first thing to do is to pull off the i's, and then you can collect the i's together and then break down your square root. So let's try that one more time. Let's do the square root of negative 3 times the square root of negative 5. Pause the video for a second and see if you can get this on your own. Were you able to get it? I hope so. This would be I times the square root of 3 times I times the square root of 5, which would equal I squared times the square root of 15. And we know what I squared is. We know that that's negative 1, so that equals the negative square root of 15. So that's how to deal with this when we have several negatives in our square roots. First, always, 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 the first thing you should do is pull off the i's and then collect them. Let's do a few more examples as we push ahead. Let's say I have square root of negative 3, square root of negative 8 over the square root of 6. So like we did last time, let's pull out the i's. Now, instead of writing the square root of 8, I'm actually going to break this up. And so instead of the square root of 8, I'm going to go ahead and break it up into the square root of 2 times the square root of 4. And do you see on the top how I have all of these broken down pieces, 3, 2, and 4? Let's go ahead and break up the square root of 6 by breaking it up into the square root of 3 times the square root of 2. And now you can see why I did that. Anything that's on the top and the bottom will cancel. So square root of 3 cancels, square root of 2 cancels, and so I have just I times the square root of 4. Everything on the bottom just becomes a 1, so we can ignore that. So I times I is I squared. Whoops, not equals. I squared times the square root of 4. And that simplifies very nicely. The square root of 4 is equal to 2. I squared is negative 1, so the answer is negative 2. So in other words, this right here is just a fancy way of writing negative 2. This number is equal to the number negative 2. And you won't get the right answer unless you pull off the i's in the very first step. Why don't you try this second problem on your own? Pause the video, see if you can get it, and then I will do it. Hopefully you got the answer. I would start by pulling off the i's, and let's break up the square root of 10 into 2 times 5, or the square roots of those. And then we have another I from here. And in fact, I know that the square root of 4 is 2, so I'm just going to write times 2. Simplify as much as I can. Again, I try to show you every single step along the way. If you feel comfortable and after some practice, you can start to skip steps as long as you don't make a mistake. but it always is better to show all of your work when you're doing these. On the bottom, I just have the square root of 2. So let's simplify this a bit. Square root of 2 cancels with square root of 2. I times I is I squared, so here we go. I have I squared times, I'm going to write the 2 next, times the square root of 5. I like to put the square roots at the end. And we know that I squared is negative 1, so it's negative 2 root 5 is the answer. So hopefully that's the answer you got. Negative 2 root 5 is another way of writing this giant collection of square roots right there. Let's push ahead. 30 plus the square root of negative 8 over 10. So you should be able to see this and recognize that it's going to be a complex number because I have a real part and an imaginary part. So the first thing to do is, because I only have one number here, let's go ahead and break it up. 30 over 10 plus the square root of negative 8 over 10. This gets more complicated if there's more stuff down here, and we'll see what to do in a minute on that. So 30 over 10 is easy. That just simplifies to 3. And remember, we can pull out the I, and so I'm going to write this as the square root of 8 over 10, and I'm going to write the I off to the side because that makes it easy to see the real and imaginary part. So remember, we can simplify the square root of 8 because I noticed that a 4 goes into it. So this would be, I have the square root of 4 times the square root of 2 over 10i, just like that. And we know that the square root of 4 is equal to 2. So 2 and 10 will cancel. 2 go because it'll reduce. So 2 divided by 2 is 1, and 10 divided by 2 is 5. So up here I'm going to write the answer, which will be 3 plus, remember 2 and 10 canceled, so the square root of 2, nothing happened to that. There's your answer in its most simplified form. So that got a little bit tricky. Just know that we took the square root of 8, the 4 came off, the 4 became a 2, and 2/10 is the same as 1/5, and the square root of 2 stayed trapped inside that square root. Notice this is written as a very good complex number with the real and imaginary parts spelled out very clearly. Let's push ahead. I think I can finish this page. On this next problem, try to do it on your own really fast. Okay, here we go. Don't get fooled by these two minuses. These don't combine to make a positive because of the square root. The first thing I would do is break this up into negative 3 minus I root 50. And I would put that over 5 and that over 5. So I've broken it up. My 5s are a little hard to read, but it's negative 3 over 5 minus I root 50 over 5. And so you'll notice that in the previous example we had a plus in between them because of that plus. Now we've got a minus in between them. So let's simplify this a bit. The square root of 50 is the same as 25 times 2, and 25 has a perfect square. So let's rewrite this. I have negative 3/5 minus the square root of 25 becomes a 5, so this will be I 5 root 2. And with practice, you'll get quick at that. And I have a 5 on the bottom right there. So notice I have minus I. Here's where the minus sign came from. Here's where the I came from. The 5's cancel, leaving us with the final answer, negative 3/5 times minus I root 2, or the square root of 2 times I. And you notice I like to put a little cap on my square root signs. The reason is because that way I know where the square root ends. So I encourage you to put a little cap on your square roots like that so that you know that the I is not in the square root. These last two problems are pretty straightforward. The nice thing about I is you can treat it like a variable when you're combining stuff. So you can combine like terms like you're used to. 12 combines with negative 3. 3i combines with negative 4i. So this would be 9, because 12 minus 3 is 9. 3i minus 4i would be negative 1i, or you could just write 9 minus I. So that was pretty easy. Over here, this one's also easy. Just notice that the minus sign will distribute because of the parentheses. So this is 5 plus 2i minus 8 plus 6i. You flip the signs. That's different from the conjugate. Don't mix those up. That was just a negative sign being distributed. 5 combines with negative 8. 2i with 6i. So I get negative 3 plus 8i as the final answer. Notice that I put the imaginary part second. And so we're doing well. We have one page of this to go. So I will see you in part 3.